Welcome at PASC 2024 in ETH Zurich. I'm here with Chris Maynard from Met Office. Welcome, Chris. You were chair of a minisymposium. Can you tell us what this minisymposium was about?
Yes, thank you. So our minisymposium was discussing a common approach for weather and climate codes to get to exascale computing, where we have very complex, typically Fortran codes of many millions of lines of code, and our different sorts of exascale supercomputers with different processors typically need a different programming model for each type of processor. And so by using a separation of concerns and then a framework or a code generator using a domain-specific language to actually express the parallelism.
Was there some sort of interdisciplinarity in your mini-symposium? Because this is usually the theme of the PASC conference, but would you say that even though it's focused on weather and climate, you would have some other components in there?
Very much so. So it's very much a sort of a collaboration between computer science and weather and climate, because we need our domain science specialists to help us construct what the APIs should look like, and then we need the performance engineering and support for the APIs to deliver the performance that the science developers will want for their application.
What is the main takeaway message that you can share with us after your discussions at the PASC conference?
So there's a commonality in approaches for these different models and using different frameworks that we're trying to do a very similar thing for these different codes. If you're trying to build a domain-specific language, the subtleties of being domain-specific mean that they don't necessarily work together, these same approaches, but some things can come together and some things can leverage each other, and so it's understanding the techniques, the methods that we're trying to employ, and how do we actually express the parallelism to get performance underneath while supporting the API that means it's quick to develop the science code.
When you have these conferences, you meet a lot of people, so you always gain momentum and interest. So are there already some steps planned for the future and for the coming months?
Yes, so there's plenty of work going on for all these different models to use these frameworks. Some people are developing their own frameworks, like the Met Office is, but other groups are using frameworks that have been developed independently. And so we talk to each other quite regularly, and coming to these conferences is very helpful because we meet the framework developers as well as like the compiler teams from the vendors and the domain specialists. So yes, very, very useful.
One last question. Okay, weather and climate, of course, we all know about the climate change. We all heard about this, but what is the impact of your development on society? Why it's important to keep developing in this direction?
So a weather and climate model takes a very long time to develop with many people involved, so typically a decade or more, with many expert scientists to develop that. So that's our big investment to develop a weather and climate model. Using these approaches, these domain-specific frameworks and languages, means we protect that investment for different computer architectures, so you don't have to rewrite the model for every single new computer innovation, and that's a really powerful thing.
So thank you very much, Chris. I hope to see you at PASC 2025.
Absolutely.
And thank you for joining us.
Thank you.